Warm welcome to anyone here today. Thank you very much that you attend the webinar from Vision and Swisscom. It's about Docker and Kubernetes, and Adrian, who is going to lead you through the next 30 minutes, he will introduce you himself. And if you have any questions, Floriana and myself from Swisscom side, we are responsible for all the ISVs out here in Switzerland and close to the border. So please contact us if you have any questions. And now I will hand over to Adrian. Thank you very much and have fun.
Thanks, Julian and Floriana. And well, welcome everybody. And thank you so much for joining us in this webinar about migrating applications to the cloud with Docker and Kubernetes. Today is Tuesday, May 26th. It is 10 a.m. in Central Europe. This is live. And my name is Adrian Kosmaczewski. I'm in charge of developer relations at Vision AG. And I will be your host today. Helping me today to deliver this webinar, moderating questions, is Arno Aukia, direct from Finland. This webinar will only take 30 minutes of your time. It will provide, I hope, some useful information to guide your application migration strategy towards Docker and Kubernetes. This webinar will be recorded. It's being recorded right now and will be made available to you later on. And you will also receive a complimentary report in PDF format summarizing the most important points we will show in this webinar. So some of you may not have heard about Vision yet. So let me introduce Vision very quickly. We are the DevOps company. We empower all software developers and online businesses to be more efficient and successful through collaborative operations engineering. We operate and we automate several steps of the overall software lifecycle, from build to deployment, provisioning, backup, observability, alerting, incident management, you name it. Vision delivers 24/7 DevOps management for your applications with a strong focus on all things Kubernetes. We guide our customers towards adopting DevOps best practices, and we run a Kubernetes platform called Apuyo in partnership with Swisscom. And we have recently released our latest creation, which is called Project Sin, as well, Kubernetes related. But let us talk about our agenda for today. First, we're going to start with an introduction to cloud-native applications, DevOps, Docker, and Kubernetes. Then we're going to see a practical example of containerization of apps with Docker and deployment to Kubernetes, showing how you can migrate your applications to the cloud. And finally, we'll provide an overview of the most popular Kubernetes distributions. We'll wrap up with some answers to your questions. But let us start with a flashback. I love starting with flashbacks. In 1997, deploying web applications was a manual task. We developed the code in our workstations and then used an FTP application like the one on the slide to deploy the code to production. Needless to say, this was a very clumsy, slow, and extremely prone to errors process. Forget one file and bam, your application crashes. And worse, it was very hard to roll back changes to a previous version in case of a major bug appearing in production. Thankfully, times have changed in the last 23 years. And today, Docker and Kubernetes are the basic building blocks for the healthy apps built by sane teams. These days, we do not talk about web applications anymore, actually, but rather about cloud-native apps. What are cloud-native applications, anyway? Cloud-native is an application architecture for building and running applications, taking advantage of cloud computing. Cloud-native is about how applications are created and deployed, not where they are deployed. You can have cloud-native apps on any public cloud providers, anywhere you want, including your own premises. Because the cloud is not just public environments, as many companies run cloud-native apps on their own premises. Developers build cloud-native apps as interconnected microservices through automation so that teams can scale up and be more productive. And finally, cloud-native applications are based on open source implementations of open standards, which enables interoperability. Developers who wish to create cloud-native applications are better advised following the 12-factor application principles exposed in the website 12factor.net that you can see right now on the screen. These principles concern not only the deployment or the maintenance of the app, but rather also the design and the architecture of the application to the level of the organization of the code. Through the use of declarative formats, the development teams can automate their work to the maximum. 12-factor apps are thought with portability in mind so that they can run on modern cloud environments as well as on a laptop with minimum differences between dev and prod environments. Finally, 12-factor apps are built with scaling in mind. The 12-factor apps principles are a large subject worthy of its own webcast, and I invite you to check the 12factor.net website for more information. On the other side of the equation, we have DevOps. While the 12-factor apps principle concern primarily the technical aspect of a project or organization, DevOps principles are actually all about the human beings behind those applications. DevOps is a set of practices that combines development and information technology operation, dev and ops, to shorten the development lifecycle, providing high quality through automation built on infrastructure as code. Thanks to DevOps, teams reduce costs with a lean way of working and can react faster to changes of requirements. DevOps teams are built upon the agile methodologies, are continuously improving themselves. We at Vision, we not only use these DevOps principles, but we present ourselves as the DevOps company, and we help our customers adopt a rhythm of continuous integration, deployment, improvement, and agility. Of course, once again, the subject of DevOps is vast, huge, and it's worthy of its own webinar as well. But for those of you who might be interested to know more about DevOps and how it can help you, I can heartily recommend the book, The Phoenix Project. It's a classic in the subject, and you can get acquainted with the basic DevOps principles and see the kind of problems it can solve for you. Now, let's talk about some best practices for cloud-native apps. The teams wishing to create cloud-native apps should keep some guidelines in mind. First of all, componentizing your application in microservices brings the benefit of horizontal scalability. The automation of the release pipeline through the use of CI/CD and infrastructure as code increases your time to market, decreases your time to market, and helps your teams grow. And making your apps observable through monitoring will help you make resilient apps. And finally, the automation of the security tasks and the whole application lifecycle helps your team find the correct security issues faster. Very good. So much for cloud-native applications. Let's go to the gist of containerization. Let's talk about containers now. Where does the name containers come from anyway? Well, I'm pretty sure most of you are familiar with what is called technically called a shipping container. These large standardized shipping containers you can see in harbors and on top of ships all over the world when you're at the large in the sea. These containers are standard. They are designed for intermodal freight transport, meaning that these containers can be used across different modes of transport, from ship, rail, truck, without unloading and reloading their cargo. This reduces costs dramatically, and it's a universal standard open to all. A huge ecosystem of vehicles, trainings, accessories, tooling has grown around them, which makes it an ubiquitous choice for the transport of goods. What does this have to do with applications anyway? Well, it turns out that just like shipping containers, application containers are standard code shipping containers. Applications can be containerized. This allows code to run unchanged in various environments, from the laptop of the developers to public cloud providers to bare metal servers on premises. Containers are bundles. They contain the app that you've written, but all of the requirements they need, the libraries, the runtimes, and so on. And they run isolated from each other through what is called operating system virtualization. This operating system virtualization is not a new idea. This is something that has existed since at least the end of the 70s. The most important thing to remember is this: the basic structure of containers is today largely standardized through the container runtime interface of the Open Container Initiative project. A container encapsulates the code of the app, as well as everything that it needs to run properly: runtime libraries, dependencies, configuration files, and more. These days, developers can containerize their applications relatively easy. There are many tools they can use for that, but the most important ones are Docker and Podman. In this webinar, we're going to see Docker extensively. Docker was the original tool that triggered the explosive growth of container technology since 2014. After the Docker container format became a de facto standard, the company Docker open sourced most of the infrastructure and donated it to the CNCF, the Cloud Native Computing Foundation. In this webinar, I will use the terms container and Docker container interchangeably. As mentioned in the beginning of this presentation, decades ago, applications would run directly on the hardware and software platform provided by vendors, usually on a rack in a data center somewhere in the world, and you had to use these FTP clients to put your application in production. But during the 2000s, the use of virtual machines greatly simplified the operation but still require massive resources due to the requirements of fully fledged virtual machines. One of the biggest advances of containers has to do with the use of OS level virtualization, which makes containers share the kernel of the underlying host, makes them faster to boot. They require less resources on the host machine, and it reduces the requirements in many other ways. Why are teams adopting containers? They are a key element of collaboration and communication these days. A container is built thanks to a written text called a Docker file, which works as a written documentation template, easy to read for humans and machines alike. Thanks to this Docker file, continuous integration tools become continuous deployment pipelines. Not only you can create a container in a few seconds, you can simply push it to production just as quickly. They are portable, which means that Linux, Windows, and Mac users can all work with the same containers, and they are isolated, and they only consume the resources assigned to them. And this isolation also brings security to the table. In order to continue, I will introduce a little bit of basic vocabulary. Just like Word documents are created out of templates, we have Docker containers and Docker images. Docker image is a template, and we create one or many containers out of a single image. Let us take a simple example. To illustrate how this works, we're going to take this small Python application built with the framework called Flask, and we are going to containerize it. As you can see, it's a very simple web service, which returns a random fortune cookie of the day with a joke or some random thought. This application listens for HTTP requests sent through port 9090. You can see that on the last line of this script. Of course, this application by itself doesn't really do anything. It requires a whole lot of infrastructure around it to run. Of course, it has requirements. This is the list of the official requirements of this application. Of course, they are all installed using the official Python tools that help you install these dependencies. This is the bare minimum required for your application to run. And now we get to the gist of Docker, the Docker file. A Docker file is a simple text file that specifies from top to bottom the different requirements of a container. It starts with the base operating system, then it specifies some packages required, in this case, Fortune. These packages could be at the operating system level or at the language level, like libraries and other artifacts written by the application to run. In this case, this application written with Python is running on Alpine Linux, and you can include system-wide dependencies using the APK package manager. And then we use pip for Python-specific dependencies. These are official Python tools. This Docker file also explicitly states the user ID required to run containers. This is very important. The line that says user 1001 explicitly says to Docker, we are not running this as the root or the super user. At the end, we see the port number that is exposed to the other world. And as you can see, it is exactly the same port as the one exposed by the Python Flask application. One nice side effect of Docker files is that they become a live de facto documentation system for your applications, explicitly stating all the required dependencies. This is precisely what we mean with infrastructure as code. To make teams work better, just read the Docker file. Many popular open source projects these days include a Docker file in their repositories, and developers can use them to understand which dependencies are required in each case. It is worth pointing out as well that Docker containers are absolutely and completely oblivious about the technologies they encapsulate. You can have containers running a Ruby on Rails application, a Django app written in Python, PHP, JavaScript, C#, Java, you name it. Just take your app, encapsulate it in a container, and run it wherever and whenever you want. And this is the true power of containers. Let us see a short demo of how to create a Docker image using a Docker file and then running a container out of it. I have here a small demonstration. I'm going to click the play button. You can also click on the link below or type the link below, and you can see it on your own time. First, I use the Docker build command. The Docker build command specifies, it gives the instruction to create a Docker image out of a Docker file. So the Docker file is assumed to be in the current folder right here. This is the context of execution of the command. And we go step by step following the steps specified in the Docker file. And this happens almost in real time. It's slightly been shortened, but it's actually quite fast. I had to download the base image being Python 3.7-Alpine. So this is downloading. Then we extract the contents and we go step by step and we apply all the steps. We install the software for Tune that we need for our app. We install our code of our app. We download the dependencies and boom, we have successfully tagged an image called Vision Fortune Cookie Service 1.0. Remember this name. You're going to see it a lot this morning. I have this image now ready on my machine. This has been ready. I can write the Docker images command and I can see the images installed locally. But of course, it's not running. I cannot curl to it. It's not actually running. So what we need to do with this image is to create a container. And to create a container out of an image, you use the docker run command. We're going to specify some parameters like the fact that we are going to expose to the outer world the port 3000. And this port 3000 will map to the port 9090 that is used by the Flask application, okay? And of course, we are going to specify the name of the image we want this container to be based upon. Now, if I do the docker ps command, I can see my container. It is running, it is there, and it has received a very special name called Strange Blackwell. This is a random name assigned by Docker. Of course, you can assign your own name if you wish. But now that my container is running, I can actually curl. Curl is a command line tool that allows me to make HTTP requests. And here I get some wisdom. You've been leading a dog's life, stay off the furniture. Why not? Democracy is a form of government in which it is permitted to wander, blah, blah, blah. And now that we are wiser, we are actually very happy about this. What we're going to do next is again to see the name of our container and we can kill it. Once we got some wisdom out of our service, we can basically kill Strange Blackwell and it's killed. If I docker ps once again, of course, it is gone. It is not there anymore. Very good. But of course, since it's gone, I cannot curl to it. There's no way to get any information because it's not running. We're very happy with this service right now. So we're going to push it. And I'm going to push this, and I'm going to explain what pushing means in a few minutes. This is a way of sharing your image. You can put it on a repository so that other people can use it without having to use, to build it themselves. I'm going to go into this in a few minutes. This is again ready. And now, since it's been pushed, I can actually remove the image, RMI, Docker RMI removes an image. I can remove the image from my own repository on my own machine, on my own laptop. And there we go, it is gone. If I look for it on my personal repository in my laptop, it is not anymore. But fear not, because since we have pushed it, we can pull it back. And this is exactly what the docker pull command does. It's a very simple, very straightforward set of commands, as you can see. We are downloading it. There we go. Very fast. And now we have it ready. And of course, I can see it on my Docker images repository. It is there and everything is good. So we can use it again and we can continue playing with this image as much as we want. So that was a very simple introduction to the basic workflow of working with Docker. One of the basic ideas of sharing these Docker images with your team, the first one, of course, as I mentioned, is using the Docker file itself. Most open source projects these days include the Docker file directly baked in on these projects, which allows teams to understand exactly what are the dependencies of a project or to create an image outright out of it. And of course, the usual procedure of Docker files is to include them with the source code of the applications where they belong, so they can be versioned as well. And this creates yet another level of interoperability and agility for the teams. But what I've shown on the video is rather to literally share the container images. And it's another level of sharing rather than just going through the Docker file. When working in teams, it is useful to be able to share Docker images with your coworkers. This allows developers and operation teams to study the behavior before putting them into production, for the testing teams as well, to execute the code and performing tests on those Docker containers. Common examples of repositories we're going to see in a few minutes, which is Docker Hub, which we've seen in the demo. And these repositories could be public or private. And of course, the repository we've used in the demo, it's a public repository. And you might be asking yourself, yeah, I have code that I wouldn't like to share like that with the open world. So fear not, there are possibilities as well for those kinds of situations. There are public and private container repositories. These are the one that is the most well-known, which is the one that I've used in the demo, is Docker Hub. It's located in hub.docker.com. It's the de facto standard for sharing public images. There are plenty of open source projects who use it, like MySQL or Apache, Nginx, and so on. You've got plenty of ready-to-use images ready for you. And you've got the Amazon Elastic Container Registry. GitHub as well provides this service. However, if you would like to have an image repository to use in your company, there are several options. If you're using GitLab, actually, you already have a container repository ready to use for you. You can also use the OpenShift Container Registry in case you're using OpenShift, or you could use Apuyo as well. We do that as well. And you could have Quai, which is a public repository, which is also available on premises, and it's created by Red Hat. So many options, many possibilities. And this is how the Fortune cookie service looks like when it's deployed on Docker Hub. Ready to use, there's a small web page created automatically for it. You can add a README to the web page if you want to add some information to somebody who would like to use it. And this is actually live. You can go to this URL right now, and you're going to see this Docker image ready for you to use. But now let's go to a much bigger subject, which is Kubernetes. Anyone who has deployed cloud native applications will recognize that these are complex beasts, because even the simplest cloud application requires at least a database, maybe a few extra servers for redundancy, an Nginx server for load balancing. Then if you have features like a newsletter, you need a mail server, another server with a cron job, then maybe a message queue to coordinate all of these things together. And next thing you know, you need to replicate all of these into different environments so you can test before deploying to production. And before you know, you're managing tens of services for a single product. So just like in an orchestra, where many instruments must coordinate with one another, cloud native apps require coordination as well. Each one of its components, built as a microservice following the DevOps and 12-factor principles, must know where are the other services, in which IP addresses, and in which port. So we need a container orchestrator to make sure that everything works properly. And that's where Kubernetes joins the party. Because to solve all of these issues that I talked previously, but many more, we can use Kubernetes. It is an open source, multi-cloud application platform governed by the Cloud Native Computing Foundation, the CNCF. Kubernetes was originally created by Google and released to the world in 2015, and it's currently available in version 1.18, released just 2 months ago. Now, an important point, how do you pronounce the name? Kubernetes is a Greek word meaning governor, commander, or ruler. So the word is actually pronounced Kubernetes. I sometimes say Kubernetes, sometimes say Kubernetes. There's there's actually very funny videos on YouTube that show people trying to understand and to figure out how to pronounce the word. You can be my guest to choose the one that fits for you. I tend to say Kubernetes, which is a mix of several different things. Now, the interesting thing is that the word Kubernetes in Greek is the root of the word government and cybernetics. So clearly, it was a very good choice for a container orchestrator. To understand Kubernetes, we need to understand a little bit of terminology, because Kubernetes manages clusters of computing power. These clusters are composed by nodes, which are machines, virtual or not. These machines are all connected together, and in those nodes, Kubernetes runs pods. Pods are the units of execution of Kubernetes composed of one or more containers inside. Pods, in turn, expose to the outer world using services, which can provide not only port forwarding, but also load balancing services. Pods are ephemeral, so they must save data somewhere, and that's the role of persistent volumes. And deployments group together all of these concepts, services, pods, persistent volumes in a current set. Let us see each of these elements in detail so that everybody understands how these pieces fit together. And since we are using infrastructure as code, as you can imagine, all of these elements are described as code. In this case, we are using a different language, which is YAML. And deployments are just a group of pods making a whole application. In this case, as you can see, we are using the container we just created a few slides ago, which is the Fortune cookie service. We're going to deploy this Fortune cookie service inside of a Kubernetes cluster. Each pod in a deployment gets a unique name, and I'm going to highlight here the name. It will be Fortune container, and pods can talk to each other using those names. Application composed from separate pods don't use IP addresses to talk to each other, but rather names. Kubernetes manages the networking of all the pieces separately and transparently. Pods, in turn, are groups of one or many containers. In this case, as you can see, I have one container because that's everything I need right now, created out of the Vision Fortune cookie service image. Very simple. When you have several containers inside of the same pod, each one of these containers can talk to each other using the localhost address 127.0.0.1, which makes it very simple to group inside of a pod applications that are tightly coupled to one another. This can be very useful in some situations. One important thing to see is that here I'm giving a name to the port 9090. We see it again, the port 9090, the port of our application, and I'm giving it the name called Fortune port. To expose this to the network, we are going to use, of course, a service, a Kubernetes service. And this is a very simple thing. Here I'm just exposing port 3000, and I'm mapping that to the Fortune port, which is the one we just saw in the previous slide. This defines a load balancer type of service. Basically, this allows Kubernetes to scale your application. If you have a lot of success and many people want to know their Fortune cookies, well, there we go. Kubernetes will take care of scaling your application as needed, as you plan it. And it's everything written down in YAML files, because this is infrastructure as code. Of course, the port that you're using will depend on the application that is encapsulated inside of the application. But enough talk, let's show something a bit more concrete. In the following demo, we're going to see how to deploy the Fortune cookie service to a Kubernetes cluster. And we are going to connect to the service, interact a little bit with it using this deployment. And to do this, I am going to use a project called Minikube. Minikube, which you can see right here on the screen. Minikube is a small Kubernetes cluster that you can install in your own laptop. There are a few of these projects. This makes it very convenient for developers to test their code before they deploy it to a production cluster elsewhere in the world, in a public cloud or so on. So here we are launching, I'm using the command minikube start that launches a small one node cluster, which is the only node being my machine. It takes a few seconds. This video has been edited a little bit for speed. But here we are. There we go. Now we are using Minikube, and we can use now the kubectl command. The kubectl command that you are going to see a lot in this video. It's the primary interaction mechanism for developers and operator teams to interact with Kubernetes cluster. Through kubectl, teams are able to explore and study the current state of a cluster. They are able to perform operations on the cluster. And the operation we are going to operate on this example is actually to just deploy an application and interact with it later on. There are several subcommands to kubectl. kubectl get nodes returns, as expected, the nodes connected to the current Kubernetes cluster. And if I ask for the deployments, well, there are no deployments. For a moment, the cluster has just started. The cluster is completely empty. So we are going to push something to this cluster. And we are going to use the YAML file using the kubectl apply command. The kubectl apply command takes a YAML file and pushes all of this information to the Kubernetes cluster. Kubernetes receives this YAML information, reads it, identifies that it has to use a particular image, in our case, the Fortune cookie service, and performs all the operations required so that this cluster will actually be running that particular container as required. There we go. So we have this deployment running. I can ask, I can ask now for the status of my deployment. As you can see, right now, it's not yet ready. We have ready, we have 0 of 1 pods inside of the deployment. So let's see what's the current status of the pods a few seconds later. kubectl get pods, and now we have ready 1 of 1. We have the pod, it is running. So that means that we can interact with it. If I apply now, I need to apply as well the service. So I will apply the second YAML file that you've seen in the previous slide. There we go. We have a service and a deployment, and I can see the services that have been installed using kubectl. The Kubernetes service that appears in this command, this Kubernetes service, is the default service used by Kubernetes itself that allows the kubectl command to talk to the cluster. And this is always enabled and always available by default. Now I'm going to ask Minikube to give me an IP address so that I can talk to this service. So I can use the Minikube service command, and I get the URL. So I'm just going to use this URL, and I'm going to curl my service right inside of my Kubernetes cluster. And there it is, a little bit of fortune, a little bit of wise messages or funny quotes to tell your friends. For example, a funny quote from American Pie, why not? This fortune command is very, very nice. You got plenty of jokes and completely random quotes coming up all the time. Once you are happy using, once you've used kubectl a lot, you might want to use something a bit more graphical. And I'm using here a very minimalistic yet very useful command line application called K9s. K9s is completely open source. It is part of this huge Kubernetes ecosystem of apps and systems. And it allows you to see, in this case, the deployments, or I can see, for example, the services. I just write services and boom, I can see the service. As you can see, it's exactly the same output as kubectl. The difference being that the output, what is shown in this application is updated live. I can hit enter on my deployment and I can see the pods. If I hit enter again on the pods, I can see the containers that are running inside. And as you can see, I have a container based on the famous fortune cookie service image. And if I hit enter again, I can see the logs of the containers. And since we executed 3 requests on our pod, we have 3 requests on the log. I hit the escape key, I go back a few levels, and now I have my pod, and I can delete the pod. Look what happens. I delete the pod using the Control-D command, and all of a sudden I have a new one running. Because this pod has been created as part of as a deployment, that means that Kubernetes will ensure at every given time that the number of pods specified for a deployment will always be running. This is something that it's very convenient, because if for some reason your application crashes and your pod dies, Kubernetes will immediately launch a new one to let you know and to make your application available 24/7. This is very convenient. And as you can see, I can curl again, a little bit of wisdom, but it's not the same pod that will be answering the request. It will be the new one. The old one, sadly, is gone. I can kubectl delete as well. I can delete objects from my cluster. And of course, if I delete objects from my cluster, they are gone. I cannot interact with them anymore. As you might expect, in this case, I deleted the service. No more service, no more curl. And once you're done using your small Kubernetes cluster, you can just minikube delete and boom, all the objects on the cluster are lost forever. Very good. A very simple interaction. And let us do some recapitulation, because we've seen a lot of things. There's a lot of information going on. First of all, Kubernetes is a container orchestrator that manages clusters. Clusters consist of nodes, and Kubernetes runs deployments on those nodes. Deployments consist of pods, services, and storage. Services expose the network services offered by the pods. Pods consist of containers, and containers are built out of images. And images are built with Docker files. And this is basically the whole story that I've been trying to tell you this morning. This is exactly something that ties together. And of course, there's much more to Kubernetes, but this already gives a lot of information, and it might guide you in your path towards these technologies. This graph reflects exactly what we just said, the interconnectedness of all of these components and how do they work together and why they are so important for your cloud native applications. Let us talk a little bit about Kubernetes distributions. Teams that are new Kubernetes are often overwhelmed by the vast ecosystem and the large amount of products that have the name Kubernetes. You might have seen that online. This is due to the fact that Kubernetes as an ecosystem has a core Kubernetes project that is used like the Linux kernel in Linux distributions. You have the Linux kernel and you have Alpine, Ubuntu, Red Hat, Enterprise Linux, and so on. There are quite a few Kubernetes distributions available. Many of the most well-known are the Rancher RKE, Red Hat OpenShift. Those are in distributions of Kubernetes that you can install in your own premises. If you don't want to install them in your own premises, you can actually buy Kubernetes clusters directly from Amazon, Microsoft Azure, or Google Cloud. And of course, Apuyo, which together with Swisscom, we offer OpenShift as a service. And OpenShift, as you can see, is one of those distributions. It's a project based on Kubernetes as well. There are also managed, There's another possibility, as you've seen in the demo, which is to run Kubernetes directly on your laptop. And this is very, very convenient because it allows your development teams to be able to test deployments and containers directly on their own laptops as they develop the applications and before they move anything into a production cluster somewhere else. Of course, Minikube, you've seen it on the demo. It's a very well-known one, but I have to mention that if you already have Docker installed in your Mac or your Windows PC, you already have a Kubernetes desktop. You can go directly to the settings of Docker Desktop and you can enable a Kubernetes cluster and you can interact with that Kubernetes cluster using the kubectl command, just like you've seen previously in the previous slides. There are other projects that offer Kubernetes in your laptops, which are Kind, Minikube, Rancher, K3s. Canonical, the people doing Ubuntu, offer also micro-K8s, and Red Hat offers a small version of code of OpenShift that you can install in your own laptop. So as you can see, lots of flexibility, lots of options. Now, what about migrating your apps to Kubernetes? There are several steps to follow. First of all, it is very important to follow the DevOps and 12-factor application guidelines. This is why we've talked about them at the very beginning. It's very, very important. The second step is to encapsulate your applications into a Docker image. And for that, you need to create the Docker file, of course, that will give the template information for you to create this image. Then you are going to specify all the interconnections of those different images that make up your application using YAML files in the format required by Kubernetes. This will provide infrastructure as code, not only at the level of the image itself, thanks to the Docker file, but at the level of the deployment, thanks to the YAML files for Kubernetes. And once you have that, you can push and apply these deployments directly to your clusters and try to run them in your own laptops, in premises, in some public cloud infrastructure as you need, as your IT strategy requires it. And this is very, very important. What are the advantages of doing so? Well, there are many advantages for this approach. There's first of all, the most important one is that Docker files and YAML files are documentation and communication tools. I cannot stress the importance of having infrastructure as code. It enables all the team members to share the same knowledge about what is going on inside of those images, inside of those clusters, and to understand the working and the connections between all of the components. Docker containers ensure portability and coherence across environments. You can be sure that the application will behave exactly the same in prod, test, or in development. There are no differences, or even your own laptop. And since the same standards apply to all of the Kubernetes environments, once you know how to use the kubectl application, once you know how to use K9s or any of the many other tools available in the Kubernetes ecosystem, you are able to interact with that cluster in exactly the same way. So somehow Kubernetes has become the de facto standard for cloud native application deployment. And this is very, very interesting because it reduces the cost of training for your teams. Once they know how to use a Kubernetes cluster, they literally know how to use any other Kubernetes cluster. So in conclusion, today we've seen a few concepts that might be useful to move your applications to the cloud. There are 4 important points to remember from this presentation. First, to the adoption of DevOps principles. Most importantly, the automation and infrastructure as code, teams can communicate better. They can scale better. They have immediate access to machine and human readable documentation. They can reduce cost. They increase time to market, and they are more agile. Containers are the basic building blocks. It all starts with containers. They are portable, lightweight, they start and stop in a blink of an eye. And thanks to Docker files, they contribute to the infrastructure as code part of DevOps. Kubernetes is a container orchestrator. It acts as the director of the orchestra, deciding on real time how to handle spikes in traffic, how to allocate resources, how to allocate storage, and so on. And even better, the YAML files used to deploy services to a Kubernetes cluster provides yet another level of infrastructure as code, which enables teams to replicate entire environments in just one command. And the 4th takeaway is that Kubernetes, like Linux, comes in various flavors and distributions. OpenShift, K3s, Minikube, many others are just Kubernetes distributions. They have different levels of added value. And there's a lot of companies investing in this ecosystem. They add value in different ways. So the whole Kubernetes ecosystem is becoming more and more a standard and more mainstream. Because of this flexibility, developers can have their own laptops running a small Kubernetes cluster, and they can interact with it as well. And the last takeaway, teams don't need to migrate everything to Kubernetes right away. These various tools can be adopted progressively one by one. We know of customers who are very happy running plain Docker images. Others instead are running large OpenShift clusters with lots of nodes and lots of pods and lots of services. So you must choose the tools that better fit your strategy, your workload, and your team. There are many examples of very successful applications running as monoliths, even though that moniker is sometimes derided in the community. So hopefully this webinar has made you curious about Docker and Kubernetes. If that's the case, we're glad to offer you a free 30-day evaluation Kubernetes cluster ready to use. Just scan the QR code on the slide or go to apuyo.ch/en, click on redeem code, and enter the code that appears on the screen. I'm going to wait a few seconds so you can take a screenshot of the current slide or basically use your mobile phone. If you scan the QR code, the only thing you will need to do is to enter your email, and you will receive an instruction email for using this cluster, and you can start interacting with it. It will be an OpenShift cluster. This is what Apuyo offers together with between Vision and Swisscom. This is exactly what we're doing. But so please, I will wait 5 more seconds before moving on, so you can take a screenshot of this. And of course, you might want, I would like to have the slides. Well, we're going to send you the slides in a few minutes. However, I have to tell you something. These slides are written like a website and are actually running inside of a Docker container. And I'm not kidding. The whole thing you just saw, it's inside of a Docker image you can pull directly from Docker Hub. So for those of you who already have Docker in your machines and you feel comfortable playing with these commands, take a screenshot of this and you will get the slides and the webinar ready for you already on that image. But then again, I would like to thank you a lot. I hope we at Vision and Swisscom, we hope that this webinar has been interesting for you. And you know, migrating your applications to Docker and Kubernetes might seem sometimes not very straightforward. It depends on the complexity of your team. So maybe you might still want to have an expert helping you and showing you the way for the first time. So we remain, of course, at your service for any information. Call us at our telephone. It's already on the screen. Send us an email at info@vision.ch. Follow us on Twitter, on LinkedIn. And thanks again very much for your attention and your patience. And I hope you will enjoy playing with your Kubernetes cluster. And of course, we are going to be answering right now a few questions that you might have asked. Thank you so much.
Excellent. Thank you, Adrian, for this presentation. We still have 15 minutes time for questions and discussion, so feel free to reach out. I got one question, actually by email. You can still use the chat and question asking functions down below if you want to. And that was, how would you compare the different Kubernetes distributions, the different Kubernetes products, basically, right? I mean, what are the key features or key differences that one need to have a look at or compare?
The two most straightforward ways to differentiate these Kubernetes distribution have to do with several levels of value added on top of the core interaction. For example, very simple, if you want to use and install Kubernetes inside of your on premises with your own, in your own company, the first thing you're going to notice is that the core Kubernetes product, the open source Kubernetes, does not have any user management whatsoever. That might not be exactly what you expect from an enterprise level product. So some Kubernetes distributions include the capability of having user management. Typically, that's the case of OpenShift. Some other try to differentiate on the ease of use of the graphic tools. For example, you might not want to use the command line. You might not want to use K9S. You might want to have a very nice web page that it's updated in real time, showing the number of pods of your deployment, showing the level of consumption of resources, the CPU, the memory, the persistent storage, whatever it is that you want to take a look at. So some distributions include these tools. Not in the case of Minikube, for example. Actually, no, I'm wrong. Minikube does include a dashboard. You can do the command Minikube dashboard, and you're going to see a very nice dashboard on a web page. For example, Rancher includes a very useful, very popular web UI that it provides a lot of information in real time. OpenShift does that well. So these are all different layers of added value. And of course, every one of these distributions will target a specific market. Red Hat, it's clearly trying to position themselves as a very high level enterprise level Kubernetes. Rancher targets a different demographic. So there's a lot of possibilities. There are many, many more companies that I haven't mentioned. If you go to the Cloud Native Computing Foundation webpage, you can see all the different Kubernetes distributions available, and there's close to 100. It's amazing. But in this case, we are mentioning the ones that we found in the Swiss market to be the most common. But this is how, to answer your question, this is how they differentiate themselves through different layers of added value.
Awesome, thank you. We have a question from from Sebastian, which is, how does Docker integrate with the development environment like VS Code?
Well, there's a fantastic Visual Studio Code plugin for Visual Studio Code plugin for Docker, and it's made by Microsoft themselves. You can install it as you would any plugin for Visual Studio Code, and you can actually see all of your images, all of the running containers, all in real time. It's very handy. It provides syntax highlighting for Docker files and the whole package. It's absolutely fantastic. It's a joy to use, very well done, very lightweight. And by the way, there's another one for Kubernetes as well. You can see all of your deployments. You have a little bit of a console that updates itself as you play with your cluster. And it's great when you're using Minikube because you can actually very easily work directly on Visual Studio Code. Now, for many, many other IDEs, for example, the JetBrains IDEs, they have Docker plugins and they provide incredibly good service as well. So there's a lot of investment as part of this ecosystem of all of these tool makers, Microsoft, JetBrains, and so on, to provide very good tools for working with Docker and Kubernetes. I find that there's an excellent support, as a developer, I can say it, I find that there's an excellent support on tooling in that respect. And Visual Studio Code in particular is one of the best.
Yeah. Does the Docker plugin also like automatically enable you to like edit the code that is running in the container, or is?
Yes, so there's a separate plugin provided by Microsoft that allows you, it's based on a very simple idea. It's basically to provide Visual Studio Code developers the possibility of live editing the code inside of a deployment. So there are several separate plugins. One of them is just pure SSH. So you can connect the SSH to anything, but they have created a few that are specifically targeting Docker containers. So if your Docker container is not a scratch image, because there's still the need of having something inside of the container that actually allows you to log in, but you can log in and you can have a terminal on it, but you can still inspect the contents and so on. So this is actually also provided by Microsoft. Microsoft is investing a lot in Docker lately. There's a lot of tools around this ecosystem.
Cool, awesome. The next question is from Walid, which is, how would you compare a Kubernetes infrastructure to a classic bare metal or virtual infrastructure in terms of cost? And he specifically mentions the return of investment over time. Is it something that you want to answer?
It's very hard to answer because it really depends on the application. If you have a very simple web app that has one web server and one database, maybe the cost reduction is not that much, and actually you're adding overhead. That can totally be the case. And I know plenty of startups who are very happy running their bare metal database or Postgre inside of one server. They plug the server to a router and they have the pieces connected together, and they're very happy about it. And I know businesses have been running for decades like that. So it really depends on the structure of your app. It doesn't mean, that's why we make the point of saying you don't need to jump directly into Kubernetes right away. You can actually go step by step and take this as what they are, as tools that they can provide a certain value or not, and it depends on your context. So I don't think there's a clear answer as to how much money can you make by using Kubernetes. I think it is great for a particular kind of apps, and those are cloud native apps, particularly microservices, particularly very complex apps when you have messaging queues and you have several servers interacting with each other and you have to replicate all of that in 2 or 3 environments, and it becomes a mess because beforehand you would have to hard code IPs or DNS names, and it becomes a mess. You don't want to do that. So instead here you can have these infrastructure as code files that define the relationships, and then you just kubectl apply here, kubectl apply there, and the whole thing will be replicated for you. And if there's an error, the error will appear everywhere, which is already in itself a huge win. So that's where I think the biggest value exists.
Yeah, maybe there's one thing I could add, and that is you said if you have more than one environment you want to deploy in, right? And so, I mean, I know there's only, not everybody has the luxury of having a separate non-production testing environment, right? So if you have that, or if you want that, well, then you already have at least 2 environments you deployed, right? Testing and production. And so you have to keep those in sync. And that's something, for example, Kubernetes helps you to do. Yes. Another thing is also that there are Kubernetes services that enable you to scale smaller than 1 server, right? So if you have 1 server, you have to pay for 1 server. If you don't need 1 server, well, you're still overpaying it, right? And for example, with Apuyo Public, you can use like a tiny part. You can use like half a gig of RAM to run your application on, which is actually you pay much less than paying for a full server. Right, so it enables you that way to also scale down, but then also scale up, right? And that's not something that's very difficult and time-consuming, and you need a system for that to do on a server, right? Yeah. So maybe that's well, it's not specifically a return of investment, right? But especially more than 1 application, more than 1 deployment, and want to scale either less than a server or more than 2 servers, then I think Kubernetes provides you return on your investment.
That's right.
Awesome.
Absolutely.
Then we have a question from Adam, which is, other than Swissness, what are the advantages of Apuyo? Well, advantages compared to what? But, but yeah, I mean, do you want to take that?
Well, maybe this one you can answer it yourself. I think.
Sure. Yeah, sure. I mean, Apuyo is OpenShift. Kubernetes distribution, right? So the benefit of OpenShift Kubernetes distribution compared to other Kubernetes distributions is it's a pretty fat distribution, right? There's a lot of stuff coming with the distribution, right? There are all the output of your container, all the logs are automatically aggregated and presented to you in a Kibana web dashboard, right? All the metrics of how much RAM and how much CPU and how much traffic and stuff, all of that is automatically aggregated for you. You don't have to engineer that on top of a empty Kubernetes yourself. And so these are, there's a web GUI that you can let the platform build to containers for you if you don't want to, or you don't have a CI/CD pipeline running somewhere else. These are all features that, I mean, they're nice, right? They're nice to have, and OpenShift provides them to you. You can use them, you don't have to. With other Kubernetes distributions, EKS, AKS, GKE, they are empty, right? They might provide you, for example, the ingress, so the incoming load balancer, but that's it. All the rest, logs, metrics, stuff, you have to either bring yourself, engineer yourself, or use some other I don't know, Amazon CloudWatch product or service that they have that, of course, is then built separately, right? So if you need all of these services, if you would like to have a web GUI, if you would like to have persistent volumes, if you would like to have a container building, logs and metrics, well, then you can choose to either take them from OpenShift or you can choose to build them yourself. And for the building yourself, it's a typical make or buy decision, basically. Apuyo, through OpenShift, provides you with all of this. It's already included. Yes, it costs money, of course, right? There's infrastructure running to aggregate logs for you in the background. But of course, if you only use that, it's maybe, or you can calculate yourself whether that's cheaper to use that because it's already packaged and working, or whether you want to invest the time and money to basically build it on top of yourself. I think that's the main benefit of OpenShift versus other distributions. And Apuyo is OpenShift as a service. That means that it provides you all of this, and it provides you, of course, at Swisscom. That means that you can use all the other Swisscom services around that pre-integrated. For example, the Swisscom S3 storage service that provides object storage that is then 10 gigabit interconnected with the Apuyo platform. That's pretty fast, and so these are, of course, then benefits that you have that from running it with Swissness and with that service provider.
There we go.
If you have any follow-up questions, please do feel free to ask Adam as well in the chat. Cool. Then we have another question from Jeremy. That is, how realistic is it to migrate ERP systems to Kubernetes, and are there already cases of this? Do you know cases?
Specifically ERP systems to Kubernetes?
Yep.
Of course. Actually, we are running our own ERP inside of a Kubernetes cluster in Vision. We themselves, we actually eat a lot of our own dog food. So basically, it is totally possible. Absolutely. Totally. We've seen, actually, when we look at the range of our customers, the kind of apps they're running, we are pretty much have seen every type of database you can imagine. We've seen every type of CRM, every type of, I don't know, anything that you might want to install in a hardware by yourself. We've seen it. And in terms of programming languages as well, we've seen from all the ones I mentioned in the presentation, some weird ones like, I don't know, probably some Erlang stuff as well, Scala, I don't know, you name it. We really have seen a lot of different uses of this platform because it shows how much flexibility it brings. So I suppose that, yeah, many customers, I cannot tell for sure, but I know that we are running our ERP on Kubernetes. Maybe you know of somebody else, Arno?
Absolutely, I can do some name dropping if you want to. So on the Apuyo website, we have, for example, Adkubum. Adkubum is a software provider. I don't know if I can call them ERP, but it's like a software for, I think, insurance companies. So let's put it in the very complex software bucket, right? That do this on Apuyo, on OpenShift. So yes, using Docker and Kubernetes. There's actually quite a few like ISVs, so like producers of software that decide to package and distribute their software in Docker containers because it's so much easier to control like the environment, right? If you have to support running it on Solaris and Linux and Windows and stuff, then it's like, if you just say, hey, this is my Docker container, you can run it in wherever you want with your customer or run it on this platform. That's actually a lot easier. So they do it like that. I know Finova also do this. I think Finova, the banking software, also goes into this very complex software bucket. There's an ERP system for schools, I think, or the education stuff called HRM systems. They are also a customer of Apuyo. They also provide this as a service to their customers, so they have an incentive to package and manage that for their different customers, of course, very efficiently. I know that Avaloq is working on putting their banking suite, their core suite, also to run into Docker Kubernetes, and also some OpenShift, of course, because it's of course popular with banks, insurance companies that would have like this enterprise support agreement around that, but should be running on any Kubernetes. So there, I do think, yes, that, I mean, the biggest incentive is, of course, for the producer of the ERP software, right? Because they have an incentive to package that better. And if they provide it as a service, well, actually even more. If you are only the consumer of an ERP software, and then it's taking that responsibility of packaging it into a Docker container and then running it, you can do that. But of course, that's a pretty, well, it's an investment, right? And if you don't get any support for that from the vendor, that may or may not be interesting. Right?
Exactly.
But of course, if you run many instances of the ERP, then it could be.
That shows as well the power of the Kubernetes ecosystem, in the sense that many vendors are actually actively moving towards the platform, because they know that there's a demand for that. There are obvious advantages. Many companies are actually realizing that there are a lot of advantages, monetary or not. Could be human advantages, speed advantages, you name it. So these products slowly move into that direction. So if your preferred ERP package is not yet ready, it might be in a couple of months, maybe.
I mean, it's very similar to virtualization, right? When we started with virtualization, depends on you whether it was 10 years ago or 20 or 15 years ago or 20 years ago, right? It was the same thing, right? Let's use the same hardware platform and let's manage different stuff on top. And by reusing the hardware or reusing the infrastructure, it makes it more efficient, right? I think now, 10 years later, everybody's like, yeah, I believe that, right? And the same thing is with Kubernetes, just another layer on top, right? So instead of managing a virtual machine with the kernel and storage and networking for each and every application, you manage it once for the host, and then you have the applications running in containers, which are just thinner and more lightweight, as Adrian explained previously. And that, of course, provides you a return of investment, because you encapsulate the complexity away and make it more reusable. So I think that is a return on investment.
Very big.
Any other last minute questions? We are at the end of the allocated time. If not, well, thank you very much for the very interesting questions. Thank you for that. And if you do have any other questions, then please do reach out, and we're happy to also answer them privately, of course.
That's right. Cool. Thank you so much, everybody, for attending.
Thank you all.
Thank you all.
Bye-bye.
Bye.